Titrasi kompleksometri adalah titrasi berdasarkan pembentukan senyawa kompleks antara kation dengan zat pembentuk kompleks. Salah satu zat pembentuk kompleks yang banyak digunakan dalam titrasi kompleksometri adalah garam dinatrium etilendiamina tetraasetat atau Na2-DTA. Senyawa ini dengan banyak kation membentuk kompleks dengan perbandingan 1:1. Berikut beberapa valensinya. N merupakan kation logam dan H2Y2- adalah garam dinatrium edetat. Berikut adalah gambaran umum reaksi antara kation logam dengan natrium EDTA.
Ethylene diamine tetracetic acid, better known as EDTA, is a strong compound that forms 1:1 ratio complex with most metal ions. When a metal ion is added to EDTA, they form a complex in which the carboxyl group's negative charges form bonds with the positive charged metal ions. For the purpose of this experiment, this reaction happens in a 1:1 ratio with both calcium and magnesium ion.
Secara umum, titrasi kompleksometri memerlukan larutan standar ETA. Larutan standar ETA distandarisasi terhadap larutan kalsium karbonat. Selain itu diperlukan indikator. Salah satu indikator adalah EBT. Reaksi pada kompleksometri dilakukan pada suasana basah. Untuk itu diperlukan baper pH 10. Pipet larutan kalsium karbonat yang sudah dibuat dan dilarutkan dalam HCl ke dalam labu Erlenmeyer. Lalu tambahkan baper pH 10 dan indikator EBT. Titrasi ini dilakukan sampai terjadi perubahan warna dari merah menjadi biru jelas. Catat volume titik akhir titrasi untuk menghitung berapa konsentrasi ETA secara tepat.
Selain menggunakan senyawa ion kalsium sebagai baku primer untuk membakukan baku sekunder di natrium edetat, dapat juga digunakan senyawa ion logam yang lain, misalkan zinc dan magnesium. Di samping itu, titrasi kompleksometri juga membutuhkan indikator yang dapat membentuk alat berwarna dengan ion logam. Salah satu indikator ion logam yang paling banyak digunakan adalah eleokrom plekti atau EBT. Kompleks EBT logam umumnya berwarna merah. Setelah penambahan larutan EDTA dimulai, indikator EBT sedikit demi sedikit akan dibebaskan. Akibatnya, warna merah semakin berkurang, sedangkan warna biru semakin dominan. Bila semua ion logam telah diikat oleh EDTA dan semua EBT telah terbebaskan, maka larutan akan berwarna biru. Adanya perubahan warna tersebut menandakan bahwa titik akhir titrasi telah tercapai.
In this practical, I'm going to be doing a titration in order to determine the amount of calcium in a water sample. So I'm using standard titration equipment of a burette, pipette, beakers, conicals and a funnel. I need a 10 molar buffer solution, which I've made already using a solution of ammonia and ammonium chloride. And in the titration, I will also be using a solution of EDTA, a 0.01 molar of EDTA, which I've already produced. The indicator for this reaction is aerochrome black tea. Before starting the reaction, I'm going to first of all rinse the burette. So leave the tap open, beaker underneath. This is deionized water to rinse out the burette. But before I can use the burette, I also need to rinse the burette with the solution it's going to contain. The EDTA is going to be put into the burette. So here I have my EDTA solution. So once the water is all run out, now rinse with my EDTA solution. And now that that's all run through, we can now fill the burette with the EDTA solution. I'm now going to fill the burette with EDTA. So pour the EDTA to above the 0 point. Remove the funnel before you start the titration. So remove my funnel, because any droplets that are on the bottom of the funnel can drop in and give you false readings. Then we'll open the tap to fill below the tap. And bring the bottom meniscus to in line with the 0 point. And now our burette is full of solution. We fill below the tap and the burette is vertical in front of us. The burette is now ready to be used. Next, I need to take my water sample. I need 100 cm cubed. So I'm using a 50 ml pipette, which first of all I must rinse with the water that I'm going to be using as my sample. So I'm squeezing the water up. And then let the water run out. And now my pipette is clean. Because I'm using it as a water sample, I don't have to rinse out the solution it's going to contain. It's because the water sample is a solution that it is going to contain. So put your pipette bulb on top of the pipette. And this is my water sample to be analysed. I'm going to press the button marked S to draw the liquid up into the pipette. And this is a 50 ml pipette, so when I see the graduation mark here, and the bottom meniscus is in line with the graduation mark at eye level, I then have drawn 50 litre samples of my water solution. If you overshoot the mark, you can let the liquid run down by squeezing the button marked E. Now I've got 50 cm cubed of solution. I'm going to put this into my reaction conical, press the button mark E, and let the 50 millilitres of the water solution run into the conical flask. So you see, there will be a drop remaining at the bottom of the pipette. You hold the tip of the pipette up the side of the conical flask, hold for a few seconds, and then you deliver 50 cm cubed into the conical flask. I'll now do this a second time, and then we'll have 100 ml of our water sample in the conical flask ready for the titration. In order for this titration to work correctly, you need to add in your buffer before you put in the indicator. So a few drops of our pH 10 buffer into the solution, and then I will add the Aerochrome black tea. The Aerochrome black tea turns red in the presence of calcium ions. The tiniest amount of a spatula tip is all that's required. And Aerochrome black tea will turn red once it complexes onto the calcium ions in the sample. So we see a wine red colour there. We're now ready to start the titration. So as we titrate, we'll see the wine colour. And that's the wine colour is the complexed Aerochrome black tea with the calcium. As I add in the EDTA solution while swirling, the EDTA is picking up the calcium off the Aerochrome black tea. And when all the calcium is being taken by the EDTA, the Aerochrome black tea will turn a different colour. You should notice it's now turned a blue colour.
Berikut ini adalah jurnal kering penetapan kadar kalsium laktat pada tablet Kalk.